Can you start the video, please?
Yeah.
Well, this is part of the project where we deal with sensors data. Okay, we have 2 sites now in the system. You can choose the site, choose the building, or choose the group of apartments you're dealing with. Then it shows the sensors. You click on the sensors, and then it loads the data from the sensors for the last 48 hours, 72 hours, something like that. Sometimes it takes a little bit because now Italian site, because you choose the apartment or areas inside an apartment depending on the configuration. Again, you select the sensor, and it loads the data. As you can see, the data, I think the data usually is sampled every 30 minutes, if I'm not mistaken. And again, this function here retrieves 48 or to 72 hours of data and feeds that to our database. Should be used in performance evaluation processes that we have ahead that will be shown in the next videos. Okay, you have functionalities here. You can filter, you can sort information, you can manipulate it somehow. Manipulating meaning visually. You cannot alter data in any position in any function here, but you can filter if you want to check for the data. Okay. The next format that we have to collect information from APIs is the second video. Is that on? Yeah, is about the SparkQL that we can. It's a similar process, but using different syntaxes and so on. Anyway, these APIs, specific APIs here, looks for specific files that we're gonna IFC files that we're gonna use also in the BIMcpd, and you can have similar functionalities here. You can browse a site, look for a specific file, a list of files, and then you can import those files in the database, or in this case in the file system to be used by BIMcpd in other functions that will be explained again in the next videos.
So this is the data management tool, and the idea behind it is to import data from either be a JSON file or a CSV file or an Excel file. And the idea is being able to import the data is that you can have the data, so you can set up the metadata behind it. So for example, if you're importing something with temperature, you could have whether it be centigrade or Fahrenheit, because obviously they numbers are different. So when it comes to comparing them for the graphs and for the performance evaluation, that kind of thing, you can compare like with like. So you know that you are comparing temperature, as I said, maybe Celsius with Celsius rather than trying to compare, say, Celsius with Fahrenheit, which doesn't really make much sense. So the system itself will take in the data. You can import the data, as you can see here. They're doing date and motion. Neither which actually have any typical units, but you then can go into the performance evaluation for the graphs, and as I said, you can compare like with like. So like this particular demo here is only looking at that data set that was imported, but you can actually compare 2 data sets. So you might want to compare, say, a bedroom with a sitting room, for example. What's the difference in temperature between, in one apartment? So this is as I said, comparing a motion across a date time on the graph, and it'll show you the motion as you can see there now. And then you have a radial graph at the bottom there, and you can choose what types of graphs you can see and what you want to use. Also, with the data management system, you can also bring in IFC files. And it will break down the IFC files into the different entities that exist in IFC4 format. And on the left-hand side, it will actually contain the metadata of that IFC file. So here you can see that the project details of the address of it, the organization it administers. Obviously, it depends on how it's filled out in, say, Autodesk or whatever it was created with. And then you can sort through the IFC format and search for certain entities. Maybe you want to see how many doors, or in this example, windows that are inside a building. So you can then manipulate the IFC file.
This is my section. So yeah, we'll go through some of the data sets that were imported. So we saw that the motion one, so we'll be going through that later. So this first example is to check across different temperatures across different apartments. So like Karen mentioned, so here we're going to select multiple apartments that have been uploaded with the sensor process, like Fabio mentioned. So there's 4 different apartments, 2, 13, 30, and 32. You select the different variables, which will be the temperature. So we'll say temperature 3 would be the apartment 30. That would correspond to that. Temperature 4 would be 32. Then you select the date range that you want to test against, and so this is across 1 day, and you'll be able to see the temperature across those 4 apartments. So it'll show it in 2 types of graphs. This line graph is probably the easiest to visualize the difference in temperature. So you can see that temperature C, which was the 4th one, I think, apartment 32 is at a higher temperature than all the other ones. Yeah, temperature apartment 32. And then you can switch off whichever apartment you didn't want to and submit again. So the next example is the motion from sensors. So again, yeah, there's been a lot of going through the motion and occupancy details. So we'll say if we check the motion sensors across apartment 2, so that would be there's 2 sensors, motion sensors in apartment 2. There's one in the bedroom and one in the kitchen, I believe. So we'll be able to see how it's picked up motion across those 2 different sensors. So it's being tested across 2 days there. And you can see that you can switch off which one you want. So this one is the bedroom one. So you can see that it's not picking up motion only at certain times, obviously. And at night, and then during the day, the kitchen one is picking up it a lot more regularly. Then you can also see the if you just select one sensor, you can see it graphs this radial graph, and you can see we'll say if we go back there, sorry, you can see this would be the sleeping time. It picked up some motion around 3 o'clock for some reason, but other than that, this would be where the occupant was asleep. So then, yeah, you can see that this is the bedroom motion, and again, this is the sleeping period for that day. So yeah. Then if we move on to the next example is motion that was imported by file. So this is data that we got from Suite 5. They sent us on data. Now, sorry, I'll just go back there. This is for 2 different sensors. So we had to split the file, the CSV file, according to the different sensors before we uploaded it, like we saw in Karen's video that Karen went through. And so just to compare the motion sensors in those 2 files, we can see now. It takes a second just to, because this is graphing across a week of data. think. Them.
Yeah. So could you please play that?
Yeah.
This is an example showing the relationship between two variables from one data set. The user can select the data source that they want to use, followed by the chart type relationship. The user selects two variables to show the relationship between those variables and sets the x-axis to be one of them, and the date range is set to the start and end of the dataset. Once that is submitted, the data is displayed in an appropriate chart. In this case, it is the scatter plot. And a user can also save the query if they want to run the same query again at a later stage. This is simple to do by adding a name and a description. The data can be viewed in a table format as well. And in this example, the user applies an outlier identification algorithm, which finds outliers in the data and highlights them. Then the user can choose to either keep or remove them from the data. Here, the user selects one of the outliers to keep in the data, just to show as an example. Here you can see that they're still included in the data, and now the user has removed all the outliers. And the new chart is then redrawn and can be saved or exported. Okay, so moving on to the M&V part of the tool, users can create a new M&V project or load an existing one. The user must enter some project details. The project title is a unique name for the project. This is checked by querying the database to ensure that the title doesn't already exist. The user optionally enters the scope, project details, selects the project type, and so on, and finally can create a new project successfully. Users can create a baseline model. In this case, multivariate regression is being used. Could you please pause there for a second? So users select the data source. In this case, the Italian demo site data is being used. The date range is chosen by selecting the start and end date for the baseline model. Since we want to create a multivariate regression model, 3 variables are selected from the data source. The independent and dependent variables are selected from the drop-down list, and a 3rd variable is needed. And when adding the 3rd variable, the user can enter some values in the from and to input fields, and this allows users to split the graphs into 3 and filter them by the entered values for the 3rd variable. So when the query is then submitted, 3 graphs are displayed, and the user can, it just takes a few seconds there. Okay, the The user can then enter the confidence interval value and click the submit button to apply multivariate regression on the data, and the user can then save these models. Okay. So in the next example here, simple linear regression is used. So this is using two variables from a data source. Similarly, the data source and date range are chosen. The independent variable and dependent variables are selected from the drop-down list. And when the query is submitted, the scatter plot shows the relationship between the two variables. The user can create a linear regression model. The user can enter a confidence interval value and click the submit button to calculate the linear regression model, which is displayed in a scatter plot, time series, and a data table format. Each of them shows the predicted Y values, lower and upper confidence interval, and the lower and upper prediction intervals, and the model details show details like slope, intercept, t-statistic value, and so on. And the user can then save this model. Okay. And in the reporting period, a user can choose a baseline model they want to compare. This is one of the models they had previously saved from the baseline models part. A user can select the date range and view the baseline model, and this displays the model data in a scatter plot, time series, and data table format. And once the user accepts the baseline model, the reporting period model and savings are calculated and displayed, and this model can be saved. And the non-routine adjustments, the user can choose a baseline model that they had previously saved, and select a date range that needs to be updated, and they can enter the percentage to update by, and whether to increase or decrease by the entered percentage. And once the user clicks the save button, the graph is displayed and saved. And yeah, I think that's pretty much it.
So the next bit we'll go on to, we've covered the data management and the performance evaluation, and now we'll go through the constraint checker. So the first example we'll go through is where we load an example project that has been set up already, to show what it does once it's set up. So here you set out the details, the project title that you're checking the constraints of. Then this one has been set out already, as I said, and we'll go through that later, where the different zones have been drawn on this level. Then you set out what you want to process it for. So in this case, it'll be HVAC, sensors, and lighting. And then you set up there's libraries for each of these systems, and you select the products you want to select for. So that's for the diffuser types. Then you set up for the sensors, which is this multi-sensor one for the moment, for this one, that it's ducting, and for this type. And then finally it'll be for the lighting sensors, will be set up as well. And yeah, the lighting types you want, the products. So then it will go on to that step 3. So the next step is where it selects it places the sensors. So this one is for the ducting, the HVAC ducting. So you can see that it's picked these locations and also placed the ducting using the shortest path algorithm, Dijkstra's algorithm, to place it. Then you also set the get wiring, electrical wiring. So this is it. Did I stop it? Oh yeah, sorry there. This is selecting the sensors and the lighting areas, and once again places the wiring system in the shortest path, the suggested path. and so you can switch off the different layers. So this is just showing the wiring layer, and then you can set them all both the ducting and the wiring together, and this shows the different sensors and systems used. And then this is the 3D viewer. So this is a 3D viewer of the Italian demo site. So where you can switch off the different layers that you want, the different floors, and so if you want to create a snapshot of the project itself. So here you can switch off all the different layers. So just floor 1 is left active, and the slab has been switched off as well, so you can see into the building. So that would be the ceiling slab basically, so that you can see in. So then you can save a snapshot, and this can be uploaded into the Constraint Checking Tool. So this is where we set up a project. So an initial project. So this would be for the Italian demo site. 1 floor of that is what we've used in this example. So this would be the image that has been saved. So there you set out this is for setting out the external perimeter of the image, which would be of the floor. So you set out that by selecting the points of it, and then you click that to set it out, so it doesn't go outside that the overall extent of it. Then you set up the different zones, I think is the next one. Is that so? Okay, so sorry, this is actually setting up the electrical board and the HVAC where that ducting comes into the floor. So that's set up initially. So this one is the electrical board here. So that's where the ducting will go back to, or the electrical wiring will go back to, and it's now next you set up the different zones that you want to process. So there again you set out you click the different points to set out the zone. Within, it has to stay within the external perimeter of the